all who are attending this third webinar of the series on sustainable transport and livability. I'm Professor Ashish Sharma, hosting this webinars today. It's my pleasure to welcome all of you for this third webinar where we are having two very good presentations by learned speakers. I'll, of course, introduce them as we move forward. Let me first share my screen so that I can run a quick introduction about this whole webinar series for all those who are attending. Hemantini, can you confirm if you can see my screen?
Yes, sir, I can see. We can see.
Good. Thank you. So as you can see on the screen, this is a webinar series that we are, have started for last few months. This is the third one in the series, and today we have Professor Kazuki Nakamura, who would talk about quality of life and walkability beyond accessibility. He is a professor at Meijo University, Japan. I'll introduce him more towards the end. And we'll, followed by that, we'll then have another, very interesting presentation on enhancing urban mobility, a comparative analysis of improvement priorities for conventional and electric buses in Kathmandu City. This will be presented by Professor Pushpa Choudhary and a research scholar, co-author, Mr. Akshay Gupta from Indian Institute of Technology, Roorkee, India. This second presentation is also a published paper already published in the journal Sustainable Transport and Livability, published by Taylor & Francis, which is a joint organizer of this webinar series. So I'll quickly run through a few slides of introduction about this webinar series. The purpose is to foster knowledge exchange and propel the discourse on topics related to sustainable transport and livability. And as I mentioned, it's jointly organized by the Special Interest Group F4, SIG-F4 of World Conference on Transport Research Society, and the journal Sustainable Transport and Livability, which is published by Taylor & Francis in association with my lab, which is called as IISc Sustainable Transportation Lab. Typically, the frequency of this webinar under this series is one webinar every 2 months, and the potential speakers would include eminent researchers through invitation, as well as selected authors of papers published in TSTL journal. And I'm happy, to say that the second presenter today, is a published paper from TSTL journal, and we'll have more such presentations from the published paper of TSTL in subsequent webinars as well. Let me quickly move forward. Just to give a recap, we did our first webinar on 7th March, which was delivered by Professor Aruna Shivkumar from Imperial College London, UK. And the second webinar was on 2nd May 2024 and was delivered by Professor Ahmed Al-Ghanedi from McGill University, Canada. And today we are meeting again for the third webinar of this series. Just a brief about the organizers, the WCTRS SIG-F4, which is on livability and sustainable transport. It is currently chaired by myself and co-chaired by Professor Kazuki Nakamura, who is also, the speaker today. We have 26 members as part of this special interest group. Anybody who is joining this meeting today and have interest in this special interest group and its activities, please do write to us, and we'll be happy to have you as member of this SIG. This is the current members list of this special interest group from different parts of the world. Also, the journal Sustainable Transport and Livability, this was launched on 7th November 2023. It's a fully open access journal published by Taylor & Francis. And this is the editorial board of the journal, which you can see is quite representative geographically from all across the world, with learned colleagues as part of this journal as editorial board members. My co-editors, associate editors are Dr. Asim Kinra from University of Bremen, Germany, and Dr. Meng Li from Tsinghua University in China. And we have editorial assistant also, Ms. Hemantini. This is the aims and scope of the journal, which basically looks at explicit linkages between sustainable transport and livability, And these are the list of bullet points, the questions that the research questions or linkages that this journal is trying to address. For example, how sustainable transport interventions affect physical, mental, economic, and social being, and likewise the other research objectives or questions that you can see here, which is what the journal is trying to address. It's a fully open access journal, but for the benefit of the authors, the Taylor and Francis, the publishers, are offering currently a full APC waiver on all the authors who will, submit their papers. So please make use of this opportunity. To introduce the speakers of today, the first speaker, Professor Kazuki Nakamura. He is a full professor for land use transport planning and urban design at Department of Civil Engineering, Meijo University, Japan. Of course, he has a very illustrious, record and career. I'm not going to read all through, but just to mention, he is also co-chair of the SIGEFO and also editorial board member of the journal Sustainable Transport and Livability. The second, presentation and the speakers, Professor Pushpa Choudhary. She's an assistant professor at Institute of Technology, Roorkee. She has established a unique connected simulator lab at IIT Roorkee, which I also had opportunity to visit personally and understand. That includes car, bike, bicycle, and pedestrian simulators operating both collaboratively and independently. Her co-author and presenter for this talk is Akshay Gupta, who is a PhD student at Institute of Technology, Roorkee. So with this brief introduction, I'll stop sharing my screen. And it's my pleasure to invite the first speaker, Professor Kazuki Nakamura. Please go ahead, Professor Kazuki, and share your screen.
Thank you, Ashish.
Yeah, your screen is visible.
Okay. Hi, my name is Kazuki Nakamura, Meijo University, Japan. I'm from Nagoya, which is the third largest city in Japan. Quite the industrial city. It's a hometown of Toyota car companies. So it's quite car dependent, obviously. But it's quite good transport access, not only car, but also rail and bus. But I have a question. I'm not sure whether it's very attractive or not. That's why I'm interested in the quality of urban and transport systems. So today's talk is QoL and walkability beyond accessibility. So this is a very broad topic. So my talk is based on a couple of papers from my work. Okay, introduce myself briefly. In terms of my research background, I started my research career with land use transport planning and modeling, working in UK and Japan. Then I moved to spatial analysis for evaluation more, low carbon transport and the quality of life. We had a project 10 years ago, low carbon transport in Asia, which has quite challenging aim to mitigate CO2 emission of emerging Asian megacities, with primary case studies Bangkok. So we used quality of life as an evaluation indicator, as a core benefit of low carbon transport. Obviously, it's hard to give up economic growth, so we try to design low carbon transport in a more attractive way with QoL. This project is led by Professor Yoshi Hayashi. He was former president of WCTRS. And also, we also working with Thai counterpart, Professor Varamet Bichenson. He's also SIG chair, the other SIG chair. And also, I'm working on more local scale analysis, street planning, and walkability evaluation in Nagoya and Bangkok to explore the possibility of walking and walkable in car-dependent cities, which is quite, I think, important. And now I'm a co-chair, as Ashish introduced, I'm a co-chair of the WCTRS SIG F4, Livability and Sustainable Transport. This is quite new topic, so I hope I can give my contribution from my work. So let me start with talking about Asia. Asia is likely to be a car-oriented development. Many Asian cities experienced rapid economic growth and rapid car ownership growth, as you can see in this figure. Nagoya is car dependent, as I said, but Bangkok is more. So it's quite common to have car dependent city in growing Asian cities. Recently, there is a shift of transport policy in Bangkok from road development to rail development. For the last decade, there is extensive development of urban railway systems to establish a network of mass rapid transit. There's also, at the same time, station area development, which is made more privately with many high-rise buildings of condominium, like in the picture. These developments are more for high-income people, luxury property, more car parks, and heavy traffic congestion there. So there is a question whether transit access is property valued. We're not sure. So whether TOD works or not, that's a question. I give you some evidence of this problem. We did a survey in Bangkok. This is 10 years ago, a bit out of date. It shows access time by activity, for each activity by socioeconomic group. And we also separate them in residents in station area and no station area. As you can see, in work travel time, most people show shorter travel time in station area. And for low-income people, they have shorter travel time in station area for the other activities too. But for high-income people, they have longer travel time in station area in many activities. So physical proximity may not be advantageous for this access time. We also had a survey on the amenity and safety levels. Household house size and the streetscape and green. This is for amenity, and also we ask about safety level. For high-income people, this amenity level is higher in station areas, but for safety level, it's lower in station area for all people, all socioeconomic groups. So it may show some problem of transit-oriented development in Bangkok. That's why we think QOL is important. We need evaluate accessibility and neighborhood quality together in a QOL. In transport studies, accessibility is major evaluation indicator, which is measured based on the distance to activity. But it's also important to have a neighborhood quality, which may depend on urban design, more local scale, for various needs. These are measured more individually, but can be integrated by estimating body parameters like a weight of each indicator to estimate quality of life as a more overall evaluation index. There are several ways to estimate QOL, like utility function, to estimate body parameter, more bottom-up way, and subjective well-being. This is to to score the overall index, QOL index, more top-down approach. I'll give you an example. To estimate this utility-based QOL, to estimate value parameter. This is what we did in Bangkok, based on conjoint analysis for residential location preferences. We set a range of indicators of access, amenity, safety, then set 2 levels of indicators, good case and bad case. Then we combine them to make options of a residential location, then ask people, Bangkok people, which location is better to analyze location preferences. This is a result of value parameter of utility-based QOL. We did the binary logic model to estimate the value parameters, and this diagram shows the result. It shows levels of value parameters, and it compare by socioeconomic group from low income to high income. As you can see, lower income people value more economic indicators like rent or work, and middle income people value safety, and high income people value amenity, and elderly people value hospital too. So you can see the difference of values by socioeconomic group. Then we can apply the value parameters to estimate the QOL as a utility. It compared the stationary QOL and non-stationary QOL, and also it shows the contribution of QOL elements, access, safety, amenity by color. As you can see, for low-income people, they value access in red more in station area. On the other hand, for high-income people, they value amenity more in green. So you can see the importance to consider this quality in QOL. So we have hypothesis to specify neighborhood quality. Walkability could be one option. So in walkability theory, walkability consists of 4 components of walking needs, which is access, safety, comfort, pleasurability. These walking needs are suggested to have hierarchical structures. So once the more lower level needs is met, the higher level needs gets more important. And the top level of this hierarchy is pleasurability. This is not only about physical benefit, but also about social benefit, like street activity could contribute to this. This is so very value-oriented need. So we think this is consistent with the QOL concept, and probably QOL, the top of this hierarchy, like a happiness. So if you have positive perception of this walkability needs, it may lead to a better QOL. This evaluation framework is also useful for evaluating street design. Street design is quite complicated. There are many objects and many combined objects. It's very difficult to evaluate. But this walkability evaluation maybe more can make a more consistent evaluation, can provide more consistent evaluation framework. So it can be applicable to many street design cases. So I think this is advantage of using this QOL for street design and also walkability for street design. So to test these hypotheses, we have questions. This is what I talked today. How does walkability contribute to QOL? And how is walkability improved by street design? The first question, it's based on the relationship between walkability and the QOL. I just have a talk based on my paper published on the journal Cities. To confirm the relationship, I used subjective well-being indicators of QOL. This is scoring the QOL indexes. We set various QOL outcomes as indicators based on well-being, like economic well-being, physical well-being as a personal QOL outcomes, and social well-being as a social outcomes. And we also more overall residential satisfaction, including attachment as a spatial QOL outcomes. Then we analyze the impact of both walkability at the bottom, including street accessibility and street quality of safety, comfort, pleasurability. So based on this structure, we try to analyze and quantify the impact. We did a survey in Nagoya, asking about satisfaction level of QOL and walkability with 9 points of satisfaction from -4 to +4. These are indicators in analysis of QOL. It can be classified to work, health, family, community, and attachment. It shows an average score. The results show relatively high score of work, travel, environment, and residential satisfaction, but some poor score in health and community. So it looks good in terms of residential satisfaction, but there is a problem in QOL. We also had a survey, in the same survey, asked about the walkability. The left-hand side, the graph shows the transport mode by activity. As I said, Nagoya is car-dependent city, so car travel, we have many car travel, but we also have many walk travel too, particularly for exercise, for physical activities, and also for education community, for social activities. Then we evaluate walkability for some indicators like this. It includes work access, shop access, and some other personal access and social access, and street quality. The results show relatively high score in shop access, but poor evaluation in work access and some of personal and social access. It includes some access to social activities with more walking. In terms of street quality, safety and comfort is relatively good, like this, but not pleasurability. Yeah, then we use this indicator to analyze the relationship with structure equation modeling. So we try to analyze the relationship, walkability, and the QOL. In walkability, street quality, and the street accessibility, there are two street accessibility showing the impact on QOL. Work access and social access. Social access is local access I just showed. And also work access, including walk to work, as I shown. And also urban scale accessibility is included travel time to work as a whole. So the result shows the significant impact of street quality on personal outcome, QoL outcome, and spatial outcome than work accessibility, which is normally the major focus of transport study. There is also importance of social accessibility like this. It has an impact on social outcomes and spatial outcomes. It also has influence on street activity, social access to street quality, which may account for the social benefit or social benefit of walking needs for street quality in walkability. And this personal outcome and the social outcome are interrelated. So this street quality affects not only personal outcome, but also social outcome. In this way, we can confirm the impact of walkability on quality of life. Then next question, how is walkability improved by street design? This may be more useful for planning and design in practice, hopefully. This is based on the paper published on Environmental Planning B. In this paper, we try to model walkability evaluation in a way to evaluate street design with a range of perception indicators of walking needs. In street design, conflicts are likely to occur in areas between roadways, walkways, buildings, which is called buffer areas. So it's important for urban design to design this buffer area by accommodating vehicles, activities, including pedestrians. So we evaluate this with perception, access, safety, comfort, feasibility of walkability, walking needs. But in real situation, we can experience very limited perception because the real experience or real environment is quite limited. So it's maybe useful to apply wider range of street design from international case studies, particularly quite a big difference between Asian cities and Western cities. Maybe Western cities is more advanced in terms of walkable environment. So it's more difficult to perceive this top level needs feasibility. So this wider range of street design can help to evaluate this higher range of walking needs. To get higher sensitivity of this evaluation, it may be also useful to have virtual experience using visualization technologies like head-mount display or 360 cameras. So we gonna evaluate based on this framework and using these devices. These are evaluation indicators. As I said, the perception of streets are based on walking needs. Each walking needs have several indicators like this. I just levered the walking needs of access to convenience because access is hardly evaluated from street scene. So I just rename it to convenience. We also had the indicator of behavior willingness. So perception, the hypothesis is perception would affect the behavior willingness. So we have indicators of dropping in, passing by, staying, and dropping in according to the level of engagement of street activities. We also set a list of street design indicators. As I said, it's usually difficult to the robust indicators of street design because it's very complicated. We just chose these indicators from literature review, then classified it by areas of building, walkway, and roadway. Some indicators are located more than 2 areas, which suggest street buffer design, including street roof, bench, bender, staying pedestrians, and parking cars. In this study, we had the case studies from different cities, different countries, Nagoya, Bangkok, and also Brisbane, Canberra from Australia. As I said, Nagoya is car-dependent city, so many big road. So we chose the boulevard in the city center. It has quite wide, big sidewalks aligned with big buildings like department stores. Bangkok case study streets are more local streets called sois, which are located many in city centers. These are used for living service, but also for many local shops, and quite heavy traffic too. Brisbane and Canberra, they have a pedestrianized zone in the city center. So we chose a case study streets there. This is more mixed use area, so there is a range of building types. Then we do experiment of walkability variation. After answering profile question, we just show the video, 360 video, to watch with head-mount display like this. If you move head, you can see whichever part you want. Then evaluate the street. So repeated this process for 4 case study streets in random order. The subjects are 50 university students. We ask them to score 10 points to evaluate design and walking needs. This is a result of subjective evaluation of street design. It shows the difference of case study areas. Like this, Nagoya has more street trees and walkways according to our city planning. And Bangkok has more traffic in roadways. And Brisbane, Canberra has more indicators in building areas, which may be to do with buffer area indicators like this. And this is the result of walking needs. Overall, you can see higher scores in convenience safety, the lower level needs, and lower score in higher level needs. It may suggest the difficulty to achieve higher level needs. Hard to be satisfied with this. So it shows some difference. Bangkok is relatively low score, but it has relatively high score for vibrant. Maybe more traffic and more pedestrian could generate this atmosphere. And Brisbane, Canberra has overall high scores for all the indicators, particularly high for higher level needs, maybe attributed to the buffer design. Then we did the SEM result to show the relationship the street design that has impact on walking needs is factored to walkway, roadway, and activity. This includes many street buffer design. And walking needs, we have 4 needs, and also we have internal paths to show the hierarchy of needs. And there is an impact of street design on walking needs. There are various impacts, but particularly interesting impact is activity. It shows a negative impact on convenience, safety, but positive impact on pleasurability. It also has an impact on behavior willingness, and particularly from higher level needs. We did this analysis for international comparison. So we did this in Nagoya and Bangkok and compare the result. There are some similarity, like higher level needs have more impact on walking willingness. And also some activity affect the higher level needs, it's common. But interestingly, the content of higher level needs have some difference. In Bangkok, safety is included in higher level needs. It may reflect the different stage of higher level needs according to urban development stage. So maybe effective urban design depends on the stage of urban development, it suggests. Yeah, that's almost all. There are a lot more to do for further research, but I think we are currently applying the data science techniques to measure urban design with image recognition, or try to visualize more with 3D street model, urban model. And also we are applying VR with motion capture to get more immersive. By doing this more multidisciplinary work, I think it opened up new opportunity of analysis for smart urban planning to not only evaluate but also design new vision. So I think this will contribute a lot to the livability and sustainable transport. Yeah, that's all from me. Thank you.
Thank you, Professor Kazuki Nakamura, for a wonderful presentation on how do you understand walkability together with quality of life. It was, excellent, combination of different case studies that you took from Bangkok, from Japan, and then comparing with several other international cities. For me, especially, the focus on subjective well-being and several aspects of that. How do you connect it to street design, streetscape, and interestingly, the use of virtual reality that you mentioned for walkability evaluation, including on the dimensions of QoL, is very interesting for me. I'm sure the participants also enjoyed. I request participants to please put your questions in the Q&A chat that we have. If there are any questions that anybody would like to ask to the speaker, we have about 10 minutes for taking questions for Professor Kazuki. Okay. Yeah. Professor Kazuki, you can hear me?
Yeah, sure.
I'll read out the question for you and then you can respond. So this is a question from Mr. Punabit. And what he's asking is the experiments, what I understand, were conducted in late 2020, a period when COVID-19 pandemic could have influenced pedestrian behavior and perception of public spaces. The pandemic's impact on walking habits and street use might skew the results, making them less applicable to post-pandemic urban scenarios. So this is his comment, and he's asking for your reflection on it.
Yes, many of my work is before the COVID, so that's a limitation. But I think pandemic or COVID has a good opportunity to experience walking, I think, even in car-dependent cities. So it's like a sort of extension of virtual reality experiment. So now people realize the benefit of walking, even in car-dependent cities. So I think it's good for us to how can I say, to evaluate walkable environment. If there is more open, I mean, the people are more open to discuss this kind of change, even in our city. We are more car dependent people, but they are also thinking about health or other well-being. So walking may be a good opportunity. So they are they start realizing this new benefit. Maybe this is thanks to the pandemic COVID. So I think these changes help our research and could support or accelerate our findings, I think. Yeah.
Great. So while we may still have few questions from the participants as I wait, maybe I can ask. I mean, you presented a segregated, data based on the income groups and for several of the data that you collect in Bangkok and so on this, how this QL evaluation and on the parameters is differing. But did you also had some data based on gender among male and female, how the perception and evaluation of QL differed?
Yeah, of course. We have data of gender, but we don't show today. Generally, the gender difference shows.
I mean, any observation that you may highlight here?
Female people care more about safety. I mean, they are more strict about evaluation. Probably they are more familiar with walking, so their standard to be satisfied is higher than male, in my impression. So I had several surveys, but many of them showed the lower score from female people. So that's quite interesting. That's probably that shows some values of gender difference. Yeah, I haven't analyzed detail yet, but that's my impression. Yeah.
There's another question, related to the first study that you presented in your slides. And the question is, walking mode share is higher for education and exercise. Any insights concerning the age, related to age, and whether walk mode was used by school children and elderly?
Yeah, at least yes. For school children, they have to walk, so no question about that. For elderly, sorry, I haven't analyzed it yet. But I think they, at least in Nagoya, in Japan, in my city, they are more car dependent because they grew up, or they just they spend their working age in motorization period, so they are more familiar with cars. So they are quite captive. Very difficult to change their travel behavior. So they are now getting old and elderly people, and they are still driving. This is a big problem in Japan. They are causing many traffic accidents. But yeah, but they, at the same time, yes, they are starting to realize the health problem. If you just driving too much, you have problem with health. So yeah, I haven't analyzed the detail yet, but I think it's very important and interesting topic to analyze more. Yeah, thank you.
Also your experience with using virtual reality, you did mention a lot of future directions. How much do you see this differs based on, say, actual living lab experiment versus a virtual, reality experiment. Did you get opportunity, or are you planning to, say, compare the evaluation, say, of same street where actual implementation of pedestrianization or walkability might have happened, and the same is evaluated in virtual reality?
Yeah, I haven't compared the real and virtual environment, but I compare different visualization devices like just video and motion capture devices. What's the difference? It shows the difference of sensitivity. For example, if you get immersive, you get more sensitive to traffic movement. It seems in virtual environment, people feel distance. People are more sensitive to distance, and particularly distance to moving object. So for transport design, I think this VR may be more effective. But on the other hand, if you see activity place, it may be better to have a movie. I mean, you have more wider view. You don't have to care too much about traffic, but you can widen your view. So there are different characteristics of the device of VR. So yeah, I also gonna compare the VR and the real, in the future. Yeah.
And the related question participant has asked is, how data collected through VR is validated, and is there will the perception change between VR and actual experience? How has been your experience?
Sorry, say again. What's the question?
How the data collected through virtual reality is validated, and if at all you have compared, do you see any perception change with VR and actual experience?
But varied. I'm not sure if I answer question. I got the data with the experiment to students. So we did it in a, actually we did it in a lecture time, and yeah, that's what I did. But I'm not sure about the question. Sorry, I can't.
Thank you. There's just a couple of more questions that I can take before I invite the next presenter. One participant has asked your views on designing or planning safer streets for women.
My view.
Yeah.
At least we need more slower vehicles. The speed is quite, I think, important to reduce the safety risk. Safety risk, as I said, safety is a more basic need. So we need improve the safety first. Then we put more activity for social interaction. But it depends on I think the width of street. Like when we did the analysis in local street in Soi, like in Bangkok, it's too small. So if we put something like a vendor, this could be obstacles. And this could cause some problems, including safety. So probably depending on type of streets. If you have a big street and big space, you can introduce more. But if you a narrow street, you have to choose what to introduce, or if you not to put anything. That's a choice, I think. Yeah, that's my view. Yeah, thank you.
Thank you. There's a question from your co-author and our good friend Varamat, and he is asking about the PM 2.5 issue becoming more severe these days, especially during certain months in Thailand. And so what he's asking is, based on your experience in Japan, are there any other emerging factors that discourage walking?
Air pollution is not a big problem in Japan, but I think it's the weather. weather, climate change. This is big problem. Hot weather and cold weather and rainy. It's quite heavy rain, extremely heavy rain takes place a lot. These causes walking, these affect walking behavior a lot. I think this climate is one of the factor of walking environment. I think it's getting more important. Yeah.
Great. Thanks. Last question I'll take before we invite the next presenter. So this is, related to your paper that you presented, published in Cities Journal. The question is, could you explain the indicators used in mental health under the health dimension?
Mental health. Yeah. Sorry. I didn't ask too much detail about mental health. We just ask whether you're healthy in mental health or not. So it's very, very simple question. Yeah. Sorry. Just one. Yeah.
Yeah. And I think maybe the attendee can look at your paper, full paper to understand the problem.
Yeah.
So I think I'm sure there's a lot more to discuss on this wonderful topic and excellent presentation that you made and gave us this whole international perspective. We are very thankful to you, Professor Kazuki, for accepting our invite and giving this talk. And I know that it's quite late in the in terms of time for your time zone. So thanks again to you. With this, I invite our second esteemed presenter for today, Dr. Pushpa Choudhary. Please go ahead and share your screen. Yes. And of course, your co-author, Akshay. Yeah.
Thank you, Professor Ashish, and thank you for Professor Kazuki for a nice presentation that we had earlier. Now, without wasting much time, I hope I'm audible and my slide is visible.
Yeah.
Yes. Okay,
please
thank you. So this paper is typically on enhancing urban mobility, but with the emphasis on comparative analysis of improvement priorities for conventional and electric buses. And the case study was in Kathmandu City. So the work was for Rupesh's master thesis. Rupesh Kumar Yadav is the first author, and he conducted his master's because he is from Nepal. So he thought that, and he had a background knowledge also how the public buses, the transportation services are impacting people. So based on that background, we thought of formulating this problem. And Akshay, myself, and Professor Parida, Director CRRI, are all the co-authors of the paper. So now talking about the present modes of transportation in Nepal, the majority of the transportation is taken care by the roads and highways. That is the 90% movement. Then the air transportation is also there, 8%. But the rest are very minimal or maybe for the tourist purposes or limited in the length or distance. So major is through the highways or the road transportation. Now, when we are, or almost every country is trying to move towards the sustainability, and in that, many of us are trying to push forward the initiatives for electric vehicles. So similarly, in Nepal also recently, there are policies related to motorbikes or private vehicles, as well as they have specific installment of the public buses in particularly some certain cities. So when I talk about the initiatives that are taken in Kathmandu related to electric buses or in Nepal, so there is one particular term that is representing the public buses, that is the Saja Yatayat, and they have recently floated around 40 buses in Kathmandu city. And then there is some private public transportation buses also, which are run by private entities. And there are 4 in numbers or quite lesser in number. But these are the initiatives that are being run in the last, let us say, 4 to 5 years. And apart from these public transportation, there are some e-rickshaws or tempos that we call the paratransit transportation system. And then there are some shuttle services in particular wards. And then there are some government policies publicly, particularly for the buses, that in after 2022, there will be no fossil fuel public buses and only the electric buses that will be going ahead, and also additional charging stations for maintaining or operating these electric buses. So through these scenarios, we can see that they are trying to move towards the sustainability by inducing more and more of the electric buses. Now, as the scenario, the future scenario comes up, we need to understand that is there any difference? Like earlier we had conventional buses, or now we have private electric buses. So from the user's point of view or their satisfaction point of view, what would be the differences, and how we can improve both? Because conventional buses also we are not going to get rid in some years. So how we can improve those, as well as how we can improve the public electric buses. So just also to highlight that in Nepal, or the Kathmandu, which is the case study here, the majority of the public transportation is only through the buses system. There is no like metro systems or other rail system or train system are not there. Only the buses or maybe the tempos that you see, or the paratransit modes that you see. So there are conventional buses which are large in number, 2036 or so. Then there are many, large buses, there are mini buses and micro buses that varies with the size and the seating capacity, etc. So there are greater numbers of conventional buses because they are from like 1950s or so. And electric buses, as we have earlier also seen, that there are only 40. So they all run on a fixed route schedules and on the existing roadways with identified points of boarding and alighting, as well as we I'll show you that and on which routes the buses will run. That will come in the next slides. So the basic objective of the study, as I said, that we wanted to see whether there is any difference in the service quality attributes from the user's point of view for the conventional buses or for the electric buses that has been implemented. And then if we see the priority ranking, like what from the user satisfaction point of view, what could be the priority, and is there any differences in both of them, and how do we enhance that based on those priority that we have received. So this is just a glimpse to show you that like earlier there have been prior modes of transportation, different modes of conventional buses that has been there, or some tempos or the paratransit that I was talking about that also came into picture in 1990s. Then there were low floor buses. Like conventional buses are also not the very old buses. They are also now with the new features. But then in 2018, the introduction of the electric buses was there, just to indicate that the bus quality perception or the service quality perception will depend on the user's experience, and that will also be hampered by what kind of traffic situation that is there. For example, this is like a mixed traffic situation where you have different vehicle types. So the plying of the these buses will also not be that easy as you have a dedicated lanes for bus transit system. So all these factors will also be affecting, but the current study was just to know the user's point of view towards various attributes that we selected, and keeping in mind that these situation will also might be affecting. So that remains always in the background of any results or the output that we get. So this was the basic literature review was also done to identify that what kind of attributes should we take into account in the questionnaire to ask people. So there were multiple studies, and we all know that there have been multiple studies in the past to study either the, let us say, bus services or metro services to know that what kind of attributes are important for the passengers. And we mostly get to know that safety, information, fare, punctuality, and comfort. All these are the common factors that attribute. So based on that, like different attributes that are listed in the literature, we also selected some 22 attributes. Now, the methodology that we followed to answer the research questions here was firstly identifying the this site selection that we did. Then we identified the attributes. And we also collected some pilot survey, and based on that also the selection of attribute might change a little bit, and the formation of the question. So for that 60 participants were selected. All of these, let me clarify that all these participants were from the Kathmandu or the area where we have conducted the study. Then the main survey was collected. For conventional buses, there were 526 responses. And for electric buses, there were around 400 or 388 responses that we received. The comparative difference is there because the number of conventional buses themselves are more, and hence the users are also more as compared to the electric buses. Now, what kind of information that we gathered was personal information, depending on their demographic and socioeconomic characteristics. Then what kind of travel characteristics. Then mainly we focused on the service quality attributes, which we are going to talk about this in this paper. Also the satisfaction rating, overall satisfaction rating, to associate the satisfaction rating with the service quality and all these other characteristics. Now, from the analysis point of view, we took a little bit different approach than the usual one, which is firstly, we identifying how much is the strength of each attribute. For example, you are asking some, let me just give you an example. For example, we are asking like these service quality attributes, frequency, network coverage, convenience, or accessibility. You ask people to rate like whether this service quality is currently worst or the best in terms of these attributes. So if the response is like if they are satisfied with that, it will come out as strong, or otherwise it will come out as weak. That is through the reference rating that I'll tell you or in the coming slides. So basically that we identified the strength of the attributes, then we identified the importance, and that also we took two approaches. One is the OLR approach that is going to tell you the significance of each attribute and the quantification of each attribute on the satisfaction level. The other was the random forest approach, which is more of a machine learning approach, and which will give you the factors which could be more important based on their reference score that we get. And eventually, once we get the strength and we get the importance rating, then based on the three-factor theory, we have identified the priority ranking. And based on the result, based on that only the results and discussions are made. Now, the study area, as you can see, is Kathmandu and city, and this you can see clearly. You can see that the green line here is showing the electric buses route. So you can see that it is only on the it's the ring road of the city, and it connects to the major points of the city. So currently, it is operational only on the ring road or the major part of that highway route. But on the contrast, the blue lines, which are showing the conventional buses, are running within the city or connecting to these areas to a little more extent. So you can see the route or the network coverage or the operations are much more large for the conventional buses as compared to the electric buses. And now coming to the data that we collected, So as we mentioned that for conventional there are 526 samples, and for electric buses there are 388 samples, and these are the samples which we have collected as the final samples after removing some outliers or some invalid samples that might occur in the questionnaire survey. So if we can see the ratio or the demographics of these data set, we can see that in both the cases we had lower female participant as compared to male participant, but the numbers remain quite high. It's not very much differences there. And if we talk about the age categories, we can see that mostly 20 to 50 years of age. Those are the people who have participated in the survey, both in the electric or conventional buses. And as well as if we talk about the education level, they are having either graduation or I mean, that varies differently, even the uneducated or the postgraduated and above. So there is a mix of the responses that we have received, but I guess it's the graduation that can also be seen that the people who are using the services were like the majority of them were students. So that indicates that the qualification, educational qualification. So we can see that students and others or the employees or homemakers are the main people who have we have collected the data or who appear to be in the buses. So let me clarify, the survey was conducted on the bus routes, on some particular bus routes, some particular location where people were actually using those type of buses. Either they have used the conventional buses or they have used the electric buses in front of the responder only. And after that only it has been asked that, because they know that they have experienced this conventional bus, so how is their different attribute rating is. Then we can also see that they people who did not have any vehicle or they have no vehicle ownership for the majority of the people who are using the buses, and the travel frequency is also highest is for at least 5 times a week. That means it is showing that we are going, mostly of them are using it for education or work purposes. So these are the basic demographics of the data that we had collected. Now coming to the modeling approach that I initially told, that if a performance score, like you have it, the respondent have answered that from 1 to 5, they have given some score. If that score is less than the average score, then it is counted as weak, or if it is the score is greater than the reference score, then we have encountered it as strong. What do you call it? Strong attribute. Then the overall satisfaction rating that we had, like highly dissatisfied to satisfied from 1 to 5 Likert scale, that for that purpose we used ordinal logic regression as well as random forest for the same dependent variable, and the independent variables were the demographics, trip characteristics, and the service quality attributes. Now, service quality attributes were also, as you can see, that they were also like from ranging from 1 to 5. So to make them like binary, we had created some dummy variables just to see that if they have given a rating on a higher side, then we have called it as higher performance rating, that is good or excellent. Or if we have coded them as low performance, when they have scored it as worst or poor cases. So in that cases, you have developed the dummy variables, which are taken as independent variables to model the overall satisfaction using ordinal or random forest model. So the variable that appears to be significantly affecting the overall satisfaction rating was considered as, if the p value is less than 0.05, it was considered as important attribute in the OLR or ordinal logic regression technique. And if the variable came out to be important from the random forest analysis by using the reference score and importance score that the variable have received. Based on that also, whether if it is having importance score greater than the average importance score, it is considered as important. So a variable or SQ variable that could come or appear as important if it has approved as a significant in OLR or its rating is higher in terms of the importance score through the random forest. So in any of these, if it is having appearing as important variable, then we have considered that as important attribute. And now if that important attribute is appearing in both low performance and high performance variables, then it is called as performance variables. Akshay probably will also be telling more details when he's explaining the results, so you have more clarity on it. That if a variable is particularly, even if it is performing low, like people have ranked as low or scored it low, and even if it is scored high, it is appearing to be important. That means this is the most important, or performance is telling you that it is the most important variables, even if people are satisfied with the current situation or if they're not satisfied in the current situation. And similarly, if you are having the performance variable quite less, or the performance is appearing in the low performance variable, importance is appearing in the low performance and it's not appearing in high performance, then it is basic. And similarly excited, or if it is not appearing important in when it is even low performed or in high perform variable, then it is called unimportant. That means in the current situations, the variable is not affecting the overall satisfaction level. And then subsequently, the three-factor theory based on this importance level as well as the strength that you have achieved here, it was counted as whether you, what is the priority ranking, 1, 2, 3 or 4, and probably Akshay will be now telling the results in terms of the attributes and the performance strength or subsequent analysis. So Akshay, I think I can stop share. Yes, you can start.
Yes, ma'am. So is my screen visible?
Yes, it's visible.
Yes.
So as ma'am has discussed the background of Kathmandu public transportation system. So now we have seen the methodology part and we are moving towards the result and analysis part. As the first part of is to determination of the performance strength, and we as already ma'am has discussed, so I came to the result part. So we have seen these are the some of the attributes which have been recorded as a strong in conventional buses like frequency or network coverage, because these are in many numbers as compared to electric buses. So these are performing good compared to electric buses, and electric buses are performing weak in those type of attributes. Similarly, if we see about the real-time information inside the buses, the conventional buses has been reported as a weak performer in terms of information, but the electric buses are found to be performing good in electric buses. And if we come to the similarly, I'm not discuss all the points. I'm just discussing some of the attributes. So if we see, for example, cleanliness, that is found to be weak in conventional buses but found to be strong in electric buses. And if we see the security against the crimes or theft, those are similar trend are showing for conventional electric buses. And similarly, that is the security to women against harassment are found weak in the conventional buses, while it is found strong in the electric buses. The major issue with the conventional buses are like they are not installed with any CCTV cameras or any like sensors, but the electric buses are now equipped with those type of CCTVs and all. So that's why they are getting the more satisfaction for these type of attributes. And after getting the satisfaction rating or the performance rating, the next step is to evaluate the importance based on our two method. That is, one is the OLR approach and second is the RF approach. So the based on the OLR approach, so we took our dependent variable, that is the overall satisfaction given by the respondents, and that is ranking from 1 to 5. So that is why it is ordinal. And our independent variables are the service quality related attribute. Those are dummy coded in the based on high performance and the low performance. So these are the ratings. So if a respondent is giving a rating like a good or excellent, so that variable comes to be in a good performance, and it will like coded as a 1. And if the respondent has given coding as was poor, so it will coded as a dummy like a low performance variable. So based on that, we will analyze their effect or the significance of the attributes on the overall satisfaction. So these are the results showing the results of OLR for both conventional electric buses. Even if you can see here, the network coverage is found to be significant in high performance for conventional buses, and for the information available at other communication technology, it is also found to be significant for conventional buses for both the high and the low performance. But if you see here that the electric buses, all the attributes are not found to be significant. These I'm talking about from SQ1 to SQ11. These are not found to be significant for the electric buses. Whenever like after the SQ11s, some attributes are found to be significant for the electric buses, like comfort, driver, conductor attributes. So these variables are found to be significant for electric buses, and security to women against harassment are found to be significant in both the cases, like for conventional buses as well as for electric buses. So coming to the next part, that is the random forest approach. So basically we employed two approaches. First is the OLR, that is a statistical approach, and second is RF, that is a machine learning approach. So RF has its own advantages. That is it's good approach to identify the features. So based on the importance ratings, we have firstly we have identified the average RF score. It is shown the here. So if the any attributes is having more than the reference score is as pointed out as the important one. So if you see here, the frequencies having a larger score than the this reference score, so it is recorded as the important attribute. Similarly, availability of travel related information, yeah, real time information inside the buses are also having importance, both the conventional as well as the electric buses. So based on these attributes, we have found different attributes, like for RF, we have found different attributes for both conventional electric buses. So I'm not going through all the detail, but these are the important attributes which are found from the RF approach. So these are the some of the graphs which are plotted for random forest method, and these are the attributes which are found to be important for the electric buses for both low performance impact and for the the high performance performance and for the low performance impact. And you can see the SQ1, SQ13, SQ14, and SQ12 are the common ones in both the these performance graphs for the electric buses. And similarly for the conventional buses, SQ22, SQ8, and SQ7 are found to be common one for the conventional buses. Those are the important attributes for based on the RF approach. So after identifying the importance for both the approaches, we need to do the we need to prioritize our attributes which we need to focus on. So based on the three-factor theory, and we identify the divide the importance type in four types, like for instance, performance, basic, and exciting, and unimportant. So as ma'am has discussed, that if the basic the performance factors are those factor, these are the very important factors regardless of the performance of that attributes. So that is how, if the respondent had given it to the low priority, the low satisfaction, but these factors are come out to be important ones. And similarly, if we talk about the basics ones, so if the performance is low, then also it is coming out to be the important one, but that is in the second category compared to the performance one. And then the next is exciting factors, which is in that factor, performance is given performance is superior, and the factor is also found to be impactful, and the unimportant factors are those which are not important. Is like if the ratings are also high, those are the unimportant factors. So if we see for the results, so for the frequency SQ1, if you see the results, so it is unimportant, because if you see the ratings for low performance and high performance, those are unimportant for this. And based on this table, if it is low performance and high performance, it is not important, so it is termed as an unimportant factor. And similarly, based on discussed methodology, other factors are coming out to be performance, basic, exciting, and unimportant. So these are some of the results, and based on these results, we have to prioritize the attributes. So after seeing that, so we have conducted, first is we have collected the performance type, so that is weak and strong, and other type is importance type. So based on these two types, we have to based on those ratings, we can prioritize the ranking of the attributes. If it is weak and basic, so it is the priority ranking of that attribute is 1, so it is highly having higher priority. And if it is weak and performance, that is also 1. But if it is weak and unimportant, so that's attributes having the rating of 5. And if it is strong and unimportant, it is also having the rating of 5. So basically, based on this table, we clustered the parameters based on their priority rankings. So these is the final result of the priority rankings of each attribute. So if you can see, the frequency is having the lowest priority for the conventional buses, but it is having the highest priority for the electric buses. As we have already mentioned, that the electric buses are very less in number in Kathmandu Valley. So that is why it is coming out as the major priority for the electric buses. Similarly, if we're talking about the availability of travel-related information, it is higher priority for the conventional buses, and it is having somehow low priority for the electric buses. As we already mentioned, that the electric buses are new ones, and they are equipped with new sensors, and they are showing the real-time information. So that's why it is coming out to be a lower priority for the electric buses. But those information are not present in the conventional buses, so that's how it is coming to out to be important for the conventional buses. And if we go to the security of women against harassment, so these parameters are coming out to be important for both conventional buses as well as the electric buses. So based on these results, we can identify the the important attributes for both type of the buses, and we can improve the service quality based on these improvement, and prioritize our resources to improvise these attributes. And further, we lastly we also tested the diversity between the gender, and we have tested with the ANOVA testing. So we have found a significant difference, and we also we have done these tests only on the highest priority indicators. So if you see that the SQ6, SQ7, and 8 are found to be significant difference in female and male satisfaction rating, and similarly SQ21 and 22. So basically, these are we have not put the name of that, but these are related to information, and these are related to security related to women. So these are found to be significant difference in the satisfaction ratings. So if we want to make a system equally available or equally satisfied for both the gender, so we need to see these factors, and we can work on these type of indicators. And for the electric buses also, we only found significant difference for SQ4, that is the walkable environment nearby the bus stop. So that has to be depicted as a different parameter, or having a difference in the perception of male and female. And coming to the conclusion parts, so we can, based on the results, we can identify the major attributes like information available through other communication technology and punctuality are top priorities for both type of buses. And if we see the sense of security against women harassment, and security against crimes, which are the priorities in the conventional buses, has come down for the second priority for the electric buses, as they have improved the security system in the electric buses. And similarly, if we see the real-time information inside bus, priority it is the top priority for the conventional buses, but it is it is no longer in the top 3 priority for the electric buses. So if we improve these type of services or the attributes, we can use the by using the electric vehicle, we can reduce the greenhouse gas emission and promote the environment friendly transportation system. And by the improving this service quality of the public transportation, we can further improve the livability of the urban areas. And these are the basic final high priority parameters. If you see the information available at communication, at other communication technology and punctuality are coming as the top priority for both the buses. However, for the sense of security and the crime against the crime are having first priority for conventional buses, but it is dropping down to second for the electric buses. And similarly, we can compare the results for the other attributes. So based on that, we can prioritize our resources. And for the recommendation part, so we have based on the attributes, we have given some of the recommendations, like real-time passenger information system should be installed in the both in both the buses, and the existing conventional buses are requiring them more. Panic button should be there, and CCTV camera should be installed for improving the security of the women. And for the comfort part, we have found that proper lighting should be there at the bus stop as well as the inside the buses. And driver conductor training should be a part of that. And for the improving the accessibility and availability part, so we should improve the frequency and the network coverage for the public buses, mostly for the electric buses, and walking environment should also be improved. So these are some recommendations based on the priority received from the analysis. And some future works can be, we have not used the socio-demographic factors while analyzing the service quality of the public buses. So those difference apart from gender and age, other socio-demographics can also be included, and their effect can also be studied. And if we have, like, we have now lesser number of electric buses, and if we have the comparable number of both electric and conventional buses, the further study should be done to see their effect while the improvement in the number of or the supply of the electric buses, if they are both are comparable number. So these can be done. So these are some references. Thank you.
Thank you, both the co-authors, Dr. Pushpa and Akshay, for very interesting and relevant presentation on this whole aspect of electric buses. How do you see how people perceive and prioritize different parameters of service between conventional buses and electric buses. And interestingly, this study is in the context of a developed economy, and in the context of Nepal, the context which has not been researched much. So that way, I think these results are very interesting and insight. And of course, just to mention to all attendees that this is a published paper in TSTL. So for full reading, you can always refer this paper from the journal. Let's see. And the questions that we have, let me see and read out. Okay, there's one question right now. I encourage participants to post their questions in Q&A chat. So one question that we have now is any inference on why passenger waiting time is having least priority? Also, can you please elaborate insights concerning journey time with conventional vehicle and electric vehicles?
Okay, so I think having passenger waiting time as the least priority would be probably because I'm not certain of it, but probably because of that they did not have that much waiting time, or they did not have that kind of problem in terms of operations that are there for the conventional or the electric buses in whatever context that is. So that could be the reason, but I think the first author, Rupesh, could tell in more details if that was the scenario or not. But this is my belief that only we will not be affected by waiting time if we are not facing it. If we are facing it, obviously we should have certain aspects of attributes related to it. The second question was on
If you can elaborate, insights concerning journey time
journey
with
time
conventional
with
vehicle
this.
and electric vehicles.
Yes, so the journey time, I think the one more aspect is as I showed in the graph or the map where the routes are elaborated. So we can see that conventional buses are going within the city and probably they will have more stoppages. And based on your origin and destination, the journey time will change. If you are passing through the city, and we are taking the conventional bus, it might take more time as compared to the electric buses because it is going around the ring road only and will have probably the lesser journey time as compared to conventional and electric buses.
There's another question, and the participant, he wants to know the greenhouse gas affecting areas from its generation. Is it a very basic question? But I need to know because if the adjacent country produce more emissions, and there is no point of increase electric buses in Nepal. I am not sure. Maybe he is referring to the
Probably
source
the
of
question.
electricity.
No, probably I think he's or she's asking about like if we are like if Nepal, a country, what do you call it, promoting more of electric buses, but it will have impact from its neighboring countries also, which might not have that much, promotion in terms of this, and the greenhouse gases, the emission from these countries might also affect. But I think that is a kind of policy related and international policy related measure that I can say, or that will take a point from that international policy aspects only. We want as an like transportation planner point of view that like electric buses, if are having any better satisfaction and having better performance, then I think we can promote it. That's what the paper was.
So there are two questions that I wanted to just ask. One was this. There's difference between prioritizing versus perception about attributes, about the parameters that we're trying to evaluate. Uh, um, a certain parameter may be on higher priority, but may be perceived in differently in terms of how it is being currently offered by conventional bus versus electric bus. So I think somewhere in your results, you, as Akshay was mentioning, that the priority about safety is lesser in electric buses compared to conventional buses. But what my understanding, it's actually, I don't think it's about priority because priority, I don't think will change whether it is conventional bus or electric bus, but it's probably about the perception that maybe they perceive electric buses more safe compared to conventional buses,
Yes.
but it remains on higher priority. So is this a distinction that we've tried maintaining or because there's a difference between the
Yes,
two?
yes, you are exactly right. So basically, in here in this paper, particularly, we did not ask them the priority rankings. We have only asked them the performance or perception scores about the current conditions. So from their point of view, how they have identified that particular attribute as like strong or weak. So currently, if the condition is better, they probably have identified it as the score would be higher. But once we do the performance and the importance analysis, like ultimately there is an overall satisfaction level also. So if that overall satisfaction level is getting affected by the attribute through the performance as well as through the strongness of the current situation. Then we are getting the priority level. So priority level is basically calculated part, and the perception is the direct administration from the user's point of view.
Yeah, I mean, as you said, as a further extension of this work, you can also do this importance
Comparison, yes.
score or the service gap analysis, say using Servicure or these kind of, where you basically understand how they value a certain parameter and how they perceive the current level and what is that service gap. That probably can help us, get more.
Right. We can certainly know whether if the performance is better, even in that better condition, I prioritize it as one or I drop the priority. So if I directly get to know from user, and then we can have a definite answer on this.
And some may also argue that some of these parameters that we are assessing or evaluating from users' perspective are irrespective of whether it's what kind of energy the bus is using, whether it is conventional or electric. So how do we? So is the difference on those parameters attributable to the type of energy being used, or is it something else that we are trying to compare?
No, I think the user, it depends on if they have the knowledge of that particular part. Like if they are perceiving that integral, that part also as while they are answering it. So that will totally depend on it. But we have not asked what is your opinion about the emissions from the conventional or the electric buses. So that remains unknown in this. But yeah, it might affect.
I'll take a few more questions. So how do you think this study is useful in analyzing the overall transportation scenario of a metropolitan area?
So that is particularly because it is telling us if we are planning for the electric buses, what are the points? Because the electric buses, they might be coming up with certain already existing features. But if they improve upon all these attributes which have come as a priority one or higher importance of ranking, for example, what they lack is I think the web application for the even the electric buses. So that was the important issue for the users. So if we are planning to engage these electric buses or the new conventional buses also, these attributes could help us, or the study could help us that in which way we can prioritize the attributes, and then if we have limited funds, where we should allocate them in which particular aspect in order to have better usability or better like uses by the people.
Okay, there's another question. How do people access bus stops? Do they connect with other modes of transportation? So he's mentioning in Southeast Asian countries like Thailand, many people live farther away from bus stops. Getting for the bus stop safety is the main issue. So walking or using motorcycle taxis is not only inconvenient but also unsafe.
Yes, accessibility remains a problem in many areas, and I am not very sure about Kathmandu City or this location that they have identified. But what I can say is that the conventional buses, as they are going within the city, will have more accessibility to from the central business district area to the other sides, as well as but the electric buses might have lower accessibility. For that accessibility, as I mentioned, that some tempo that they call or paratransit system is there for accessibility. That is also a kind of public mode And I think, or I believe that that is what used. But Akshay can correct me if he has more knowledge on it.
Yes, ma'am. So the people who are living nearby to the bus stops, they are accessing by walking. But the people who are not living nearby, so they are using IPT modes to come to the bus stops. So there are like very low number of motorcycle taxi in Nepal, Kathmandu particularly. So if they use it for a whole trip, not for the access trip to the bus stop.
Okay. Another question is it possible to check the samples collected along the same routes for both conventional and electric buses? In that case, will priority ranking change? Any insights on this aspect?
Yes, actually, that the one thing that I probably did not clarify that the like one respondent, we assume that if they are in using the conventional buses right now, they are answering from the conventional buses point of view only. But if, for example, that respondent have used the electric bus also, then it might affect the rating of the conventional buses also because they have seen the features in the electric buses. And then it might say, okay, the conventional bus, this thing is not there and this is very important and all that. So that would affect, I mean, that can affect. And similarly, the question that if we have the same route, but currently the EV routes were only limited to that outer ring road, and where the only, I think in one route there were conventional buses on that outer ring road. So kindly that currently that comparison is not done, but yeah, it might have some impact based on the overcrowding, which one is more used, less used. Like.
There's another question, the participant is asking, I would like to understand if important parameters such as overcrowding and extreme weather conditions can also be included in the questionnaire.
Yes, I think that can be included, but the service, the attributes that they have identified was from, or we have identified was from the literature review, and probably overcrowding. I'm not very sure whether it was a problem or not, because as I showed that there was a large number of conventional buses already running in that area, so that might not be a problem, but not certain of it. Akshay, if you have
Weather,
any.
yeah, weather is an external factor, not a service-related factor, but yeah, maybe
Which
some of
cannot,
these
yeah.
external factors may have some influence on the choice between the two. But
So we have taken one of the factors like a level of comfort inside the bus. So that is taken care in that particular attribute. So overcrowdiness, and I've seen one question related to noise. So yes, we have also taken care in the parameter of condition of the vehicle. So that noise particular related parameters are coming to in the condition of the vehicle attribute.
I don't see any more questions, but I think, yeah, it was quite interesting, and I think a lot of discussion that basically shows how interesting the presentation was. Thanks again to both of you for accepting our invitation. And I must say, to sum up, both the presentations today, both the presenters, thanks to them, for their excellent, contribution and furthering this whole understanding that we are trying to bring in, about these linkages between transport, its sustainability and livability and quality of life related, factors. And we would continue this series roughly from after 2 months from now. We'll again come back with the fourth webinar of this series with another set of wonderful presentations. So till then, please hold on and watch for the announcement on the fourth webinar soon. So with this concluding remark, again, thanks to all the speakers, and we can conclude the session now. Thank you, Professor Pushpa, Akshay.
Thank
Also,
you.
again, thanks to Professor Kazuki.
Thank you.
Thank you.
Thank you, everyone. Thank you.
We can close the session now. Thank you, Professor Kazuki. Bye.
Yeah, bye bye. Thank you.
Bye.